Hey guys, welcome back to the channel again. So we are solving the next problem on the linked list. It's Palindrome linked list. It's 2, 2, 2, 3, 4 in LeetCode. So you all know what's the palindrome number. So okay, if the number is from the starting or the last, and if you reverse that number, if equals, it's a palindrome number. In a simple way, okay, like if in a simple way, let number 1 to 1. This is a number given, okay, and we reverse it, so what it become 1 to 1 again. So a number, actual number, and after reversing it, if these both are equal, then it's a palindrome number, okay. And you all know the basic method of checking that palindrome number, like you take two pointer, one from starting, one from last, and if both are equal, then you just left pointer increase, right pointer decrease. And if there is a case when while loop left not equals to right till then, and if there is a case where left not match equals to right, like for 1 2 3, left to enter 1 3, if it did not match, you just return false. It is not a palindrome. If there is a match, you check until the loop condition is true. This is how you check the palindrome number actually, okay. So now it's you actually do in normal number. Now it has given you a linked list. You have given a head of a single list, and you have to check it into if it's one or no. So how do you approach this question? Okay, the basic things comes in your mind. How do you approach this question? First, I always in my previous videos, like just think of the linked list is like an array. Okay, you have given an array, you have given a, just think of an array. It's just like things of the array, like you give an array 1 2 2 1. So what do you do in an array? Just if you are given that array, you just take 1 2 2 1, and just one case you just from start left pointer and from the last point of the length, and checks what you have the by using while loop, for loop, whatever you loop uses, and the condition of palindrome or palindrome number program you just do. Similarly, you can apply that here. How can you apply this? The first things you apply that you have to take just make a vector array. You just have to push the value from the taking a time, push 1 2 2 1, then you have pushed the values, and you have now in this value in a vector. Now you in a vector, you just take next step is to do apply the palindrome number logic, simply the logic in normally, but it's the right things you have to go. Yeah, it's a good one, is a one thing to solve the problem. And this is a basically you approach a problem. If you are a starter, basically you have to approach things like I always say, just things of a array, and what approach you think of array you actually can do in a linked list. Just you have to take push in vector and apply in the vector, and your result can do. But can we have another thing to do? Surely. What other thing? We have other things, like how can we things? For a palindrome number, if you just using a linked list, we have to do in linked list only, not using an extra. So how we can do? The first approach is what I said, pushing active using the extra space. The extra space how to run. It's not a good case. Interpret might ask you to do in the linked list only. Do not make an extra array. Okay, do in linked list only. So how you approach? So for palindrome number, you know, there is a you have to find from the middle, just 1 2 2 from the middle, like 1 2 in the 1 and 2 1 in the. You just check like 1 1 equal, 2 2 equal. But in the linked list you cannot like use the pointer like now, like you not like you can add the head of the pointer, you can increment that, but from the last you cannot do decrement. You have do not have this double linked list to have the pointer previous. If it is the case, you can do something like, but you cannot do it in that case, okay, because you do not have the previous pointer, you have the increment pointer. So how to approach? So something, if you like reverse this, if you just reverse this 2 1 2 and have a mid break then here, you can just stick 1 with this one to this, like how is actually what I'm thinking of, like this is a linked list 1 2 1 2, sorry 1 2 1 2, and I say just find the middle of the links. Just this is the middle, like okay. So linked list, just like you have made a middle, and we break down from the middle 1 2 1 2 and just reverse it. Okay, just revert is 1 2 2 1 actually is the just actually is the 2 1. It's actually okay. You just have the middle and you break in the 2 1 2 and 2 1, and from the mid this part, second part, you reverse that part. So after reverse part, what it become? It become 1 2. So you have two part now. This is the first part, this is the second part, and you can easily check now, like this you make a left pointer, now to make from the mid next this is the right pointer, and you can check if this equal, you can increment till now while right not equals to null. If there is a case nothing match, you can say return false, it's not a palindrome. So how it's done? It's simply given a linked list, just middle up, find the middle element. From the middle, you know, okay, let's from the middle next. From the mid next, just reverse it, because you cannot have the previous pointer, so you cannot do like 2 pointer left and right easily. So you have to reverse in that only to check values. Okay, to easily check. So you have to check easily. You have to divide in 2 parts and reverse that right part, mid next part, and when you reverse it's 1 2, and you usually check that part and that part. When equals, if not equals, then you false. Like in 1 2 is a mid 1 and 2. It's not equal, simply you can say false. Okay. So now it's a term how we can do this. We have now understand we have two things to do. One is to find the middle element, and when up middle element we have to reverse it, and after reverse it we have to apply the logic of palindrome number. So yeah, the first, but yeah, before that, first is the base case. Base case you can think of the, if there is a singly head is null, if your head equals to null, or head singly head only one element is there, head next equals to null, maybe there's case. In both case it's a single element always palindrome, you know na, from the left right you same repeat same, simply return true. Okay, now it's the case. Okay, now you have to find the middle element. So next node mid, it will make this midi. Okay, midi, when has just call a function, just make it mid and just call up a mid f mid find. Okay, and just pass that head. Okay, pass that head. Now make that function. Make that function. You have to return the node, so list node is there. If not, just then simply void. But you have written to have to mention return type. You all know how to make a function list node, and you have given the name midf, and you are having the input list node head. Okay, now finding middle element, you have already have videos, we have to approaches. So wonderful approach, but you know, when I tell the previous approach for the building, I using the slow and fast pointer. Okay, simply it's easy because n log n by log n is a complexity in doing that. So how it's doing that? When we are doing in a previous video of finding middle element, we are studying the slow and slow and fast from same pointer. So the middle element in the even case is always the second one. But you know, we have in this case we have need the first middle element, because we know we want to get the link of the second element. No, because if you get the same element, how get we link to this? So we get actually the link that we connect to the other halves. So we need that middle element. That's why we have to think. So I already tell in that video also, for did if you have to need first middle element, so you have to start fast from the head next. Make list node is start slow is same, you can start off head, but fast it will start from head next, one pointer extra already have been solved in the previous video we have made for that fast pointer. You start from head next. Okay, now you simply how you going to do is, while you have cases, simply while fast not equals to null and basically mistake or what, so you have to think of that you are doing correctly. Basic mistake can be happen, so must be think of first next not equals to null. So this is the action, and after that you have to increase fast by twice, fast next and slow by 1, slow equals to slow next. Okay, just this and where middle element is already in slow, you all know, so just return. Now we have that middle element, we have now have that middle element. What have to do next? Just store that element first in something right part, you can say up right part is what mid connects, because this part is the next. So mid actually the 1 2 second, but we have second part mid next. So mid next is your right part, starting next part, right part actually. To mid connects in the right part. Okay, and what we have to done, we have to reverse. Before checking, we have to just reverse it. We have already know, so now we have just find a mid. Now another things is to do happening, reverse that part. So okay, the reverse that part will be what we store in, point to the mid next point to the reverse part. So mid next point where you, and just make a function reverse. Okay, and what you pass in R, because you have to reverse from the right part, and right when you reverse it, you have to just link it to the mid next. Mid you have find 2 and mid next is that links. So just 2. Now make an function for reverse. Simply let's know what reverse we have hatch. Yeah, there is you can do the reversion on the linked list using two methods, like one is recursion and one is iterative. Yes, in this video just going for iterative. If you want to know the best, you can find in the internet on any video you have that solution, so it's not a tough one. Okay, just not making that video because it's not a big one, it's a easy problem, so it's not an important one. Is a basic one, you can think see of yourself, so I'm not making that in video. No, let's note star current. You know, iterative we have to make a current pointer, not much explaining the logic of the reversing. You know the reversion, and you can see the video how it's the logic it's actually work, because it's taken a lot of time if I explain it there. Okay, and you all know it's for revision, so you must know the logic of basic how you reverse. You can just apply your thinking of yourself, your things how you done reverse in normally array, if that's something you have to do, like something like, yes, different from array, but yeah, you can start thinking of the logic from that only. So while current not equals to null, so you have to store the next you have to store current connects actually, that is means of the next element you're storing current next. and what is the current connects. If you are just revising, you can think of its current, like if the current elements like now it's the last one, so what it's you and reverse, so one is to how to link with previous actually you would think like 2 is previous and 1 is the current. So what do you think, you link 1 with 2, so that's is something current next is linking to previous. And what previous you will now be a current, and current will be your next. You have stored the next element next, so it knows just point it, and return previous, because you store your first after reversion, the first part of the like one is here in the previous, so return previous. That is how you reverse. Now you have find made, you have find reverse, just you have to apply the pending logic here. For you have to best make two node left by starting from the head itself, next node left, just point it to the head, and right from where you write, we can just comment it from what you think. Before watching that, you can just comment here, but I think you all know. So right, what do you think? Right is start from yes, mid next, obviously mid next. Okay, not R. You think you can have, but before, because R is previously pointing to, that's why, and mid next is updated, so it might be like updated, but you must have safe solution to have mid next here. Okay, now just stop the blending normal blending while right, because it's in the array you have just checking the left dot equals to less than equals to right, something like, okay, but here you can just, here is a linked list, it's and some null pointer, and right will stop first, because left, it, if you think of left you actually have to right, okay, but not, you have to print from the right, so you have parting in two ways. So because it's not from the last point, it's from the start point and middle of the window, and middle pointer is something at the end, so right is the right middle pointer, middle next actually. So while right not equals to null, until you have to just check is, so basic, if left value you have to check left value not equals to, we make it not equals easily for right value, if not it means not a palindrome, just return false, no need to do anything, it's already means it's false. Okay, if it is trueing like one match, then you have to check, so you have to increment left and right also, left equals to left next, and right equals to right next. That's easy, not a big one here. I can think you can understand that it's not a mix of issue, and if you are just coming out of the while loop, it means it's a palindrome number. So before returning just true, just make me it correct, you have just changes the null list, so just correct it, the same the approach, you have reverse, just r, you make r, so just apply mid next again and reverse it, and mid next again, same approach, like if you reverse that to one part again, for reversing like before, you can doing same, you just do the same step, it's always in every case, if you are doing, have to do the previous step, it's already what is already there, have to done after changes you have done, and you want to take to the previous, just do the steps you have done to that, it will make you the previous one changes, in most cases it happens. Okay, so you just have to think, because you reverse, the reverse logic is again you have to take and submit next and apply for reverse, and just r is mid next, it just reverse, and your original English is there, and you just return true. It's a good practice, sometimes you not return best return true, it can work, but it's not a thing, because you change it to might correct the things, just done it. No, yeah, it's updated, let's submit it. So it's corrected, yeah, it's easy one, not an tough one. I think you can understand the solution, the part you can do using the vectors, stage vector, it's order and but and size is not an order one, so that is something you have done in a better approach. You apply like how the complexity is going, it's already order one, it's not index, because this is something you apply order when this is apply order and plus one, 3 over order one is simply order one, and space nothing order one, especially you have to that thing. So that is how you solve this problem, and I will suggest you to see the problems, and it's a good one. Yeah, obviously if you are to see the reverse of linked list, if you are just starting, it's for, as lady said, that we are making video which I'm practicing, and it's good for the important question, because making from the starting it's like a long time to repeat, because it's not done the way I am thinking of today currently. So just if you have to think, you can watch in YouTube, it's very, there is various YouTubers you can watch and just practicing, and then you can hear just the thing. And thank you for watching, guys.